As Scott said, I'm Francisco Ziot, developer advocate at Ivan, which is a nice company building open source things in the cloud of your choice, all managed for you. So let's not waste any more time. If you're here, you are somehow interested in kind of event-driven application, and probably you are familiar with Python. On the other side, you may wonder, what is Apache Kafka? Why should I be interested in Apache Kafka? Well, let me tell you the full story. If you are a developer, you will be either working on a kind of new shiny application that you just created out of nothing and you are exposing to the world, or you are part of a large company and you inherited an old application and you have to support it, to extend it, and maybe to take it to the new world. No matter if new or old, I've never seen an application working in complete isolation. You will have components within the application that needs to talk with each other. And if you expose this application into the world, you will have this application talking with other applications around. So let me share with you a secret. Apache Kafka is what makes this communication easy and reliable. But now let's check a little bit more what we were doing in the past and why Kafka is relevant nowadays. If we go back in history a few years, we had our applications that were already there, and they were already kind of creating events. And most of them were storing events in backend database. Or other applications were reading from the database and passing those events into the application itself. Most of the times, however, the communication of the events wasn't done for every single message. The application was piling up a series of events and then pushing them to the database. Or the same application or another application was reading from the database in batches. This meant that we were adding a constant delay between when an event was created in the real life and when we were pushing it to the database, or from when the event was already available in the database and we were able to read it. On the other side, we now live in kind of a fast world, and we cannot wait batch time. We cannot wait 5 hours, 20 minutes, 10 minutes in order to receive a certain event. We need to build event-driven application. What are those? An application that as soon as an event happens in real life, they will immediately need to know about it, start parsing it, and probably take the outcome of their parsing and push it to another downstream application, which will act probably as another event-driven application, creating a chain of those. But before going in deep into how to create an event-driven application, let's start by defining what is an event. And, we are all used now with, for example, mobile phones. And we are all used to receive notification about something. The notification tells us that an event happened. Did someone else send us a message? We receive a notification. Did we make a purchase with our credit card? We receive a notification. Did someone else stole our credit card and made a payment? We receive a notification. As you can understand, we cannot wait 6 hours, 5 minutes, 2 minutes of batch time before receiving that information. We want to receive it immediately. And even more in this time of, for example, pandemic, we have been using a lot our mobile phones in order, for example, to create food orders and to receive food at home. And by the time that we switch on our mobile, we select the app, we select the restaurant, and we make the order, we are creating a chain or a first event that will create a chain of other events. So when we create the order, the first thing that it will be done is that the order will be sent, for example, to your favorite pizzeria. And that pizzeria will start reacting as an event-driven application and will start preparing your pizza. At a certain point, your pizza will be ready. And it will be ready at the pizzeria, not at your place. So it will be another event for the delivery people to come and pick it up and take it to your place. Now, if you start thinking about events, you also start realizing that we need to communicate those events, pass those events as quickly as we can. Because we, as I said before, we live in a fast world. So the value of the information itself is strictly related to the time that it takes to be delivered. Going back to the delivery of the pizza, the information is useful only if from the time that the position of the driver, from the time that the position is taken from the driver's cell phone to the time that it lands on our map, the delay is minimal, as 10, 20 seconds. If the delay is 5 minutes, the information about the position of the delivery is not relevant anymore. So we need a tool that makes this communication reliable, easy, and quick. And, well, Kafka is exactly that tool. But if we have to think about what is Kafka, well, the basic of Kafka is really simple. It's the concept of a log file. Oh, sorry, a log. A log where we start storing our events as soon as they happen. So event number 0 happens and we store it in the log. Event number 1 happens and we store it. 2, 3, and 4. Even more, Kafka is a log which is append only and immutable. This means that we can write only at the end of the log. And once we write event 0 in the log as message, it's not like a record in the database. We cannot go there and change the pizza from Margherita to Diavola. Event 0 will be always like that. If something changes the reality of event number 0, we will store it as a new event in our log. Kafka allows us not only to store one type of events, allow us to store many types of events, because we all know that events happen in different types. For example, we have the pizza orders, and we can have the delivery position. So we will store the pizza orders in one log, and the delivery position in our log, in another log. And those logs, in Kafka terms, are called topics. So I have topic A and topic B, pizza orders and delivery position. Kafka, in the back, is not meant to run on just a unique, huge server. It's meant to be a distributed system. This means that when you create a Kafka instance, you are most of the time actually creating a set of nodes. A set of nodes that in Kafka terms are called brokers. And now, if we go back to our log information, to our topics, the topics are stored across the brokers, but not only one time. We store the topics across the brokers multiple times. So for example, we have our sharp pages log that is stored 3 times, following a parameter which is called replication factor of 3. And then we have the other log, the other topic, round edges, that could be delivery position, which has only 2 copies, so replication factor of 2. Why do we store multiple copies of the same topic over our brokers? Well, because we know that computers are not entirely reliable, and we could lose a node, but still, if you check here, we are not going to lose any data. Both the sharp edges topic and the round edges topic are still there available. So we understood how Kafka works on the backend. Now, let's try to understand what is an event for Kafka, since it's a platform meant to store and propagate events. Well, Kafka is really easy when it defines an event. All you need to know about an event in Kafka is that it is composed by a key and a value. And Kafka really doesn't care about what you put both in the key and the value. For Kafka, it's just a series of bytes. You can start with really easy messages, for example, where you store the maximum temperature as key and the value of it, 35.3 as value. Or you could go pretty wild, where you store both in JSON, in the key and in the value. And in the key, you store the shop name receiving the pizza order together with a phone line used to make the call. And in the value, you store all the order details containing the ID, the name of the person making the order, and the list of pizzas. You can use any format that you want, because for Kafka, it's just a series of bytes. So for example, you could use JSON, like in this case, which is beautiful because I can read as human the whole message. But if we have to think about transmitting JSON over the network, it is a little bit heavy because for every field, it contains both the field name and the field value. If we want to send the same information in a more compacted way, we can use other data formats like, for example, Avro, that detach the schema from the payload and use a schema registry in order to compact the message. And on the other side, when we consume the data, to rehydrate the message itself. So now that we understood what an event, what a message for Kafka is, it's time to understand how we can write to Kafka. And if we have an application, in our case, it will be a Python application that writes to Kafka, well, then it's called a producer. And a producer produces data to a topic. In order to produce data to a topic, all the producer needs to know is where to find Kafka, hostname and port of the brokers, how to authenticate to Kafka, for example, using SSL, and how to encode the data from, for example, the JSON format that was using internally to the raw series of bytes that Kafka understands. All so simple. On the other side, if we have data in a Kafka topic and we want to read with an application, well, this application will be called a consumer. And what the consumer does is it reads event number 0 and then communicates back to Kafka, event number 0 done. Let's move to 1. Reads event number 1, communicates back to Kafka, 1 done, let's move to 2, and so on and so forth. Why communicating back to Kafka is really important? Well, because we know, again, computers are not entirely reliable. So we know that, for example, the consumer could fail, but still Kafka will know until what point that consumer read that specific log. So the next time that the consumer pops up, Kafka will know which is the next item that the consumer didn't parse previously. In order to consume data from Kafka, all that the consumer needs to know is pretty much the same information as the producer. First of all, hostname and port. Second, how to authenticate to Kafka as before. But before, when we were producing data, we were serializing. Now it's time to deserialize, decode from raw series of bytes to, for example, JSON. And the last information is where to find the data. So which topic or which list of topics the consumer wants to read from. Now, these were a lot of slides. Now it's time to see some actual code. So it's time for a nice pizza demo. What I created so far for this kind of event is a series of notebooks. A series of notebooks that we will use in order to interact with Kafka. How to get Kafka, it's another discussion. You can have it in on-premises, or you can install yourself in the cloud of your choice, or you can use a managed service like the one that Ivan offers. What I did in the first notebook here is pre-create the environment. If we go and check on the Ivan side, I created 2 items, one Kafka instance, which is fully managed for you, and a Postgres instance. What we will see now in the rest of the demo is how we can interact with Kafka, and then also a little secret about having Kafka interacting with Postgres. So let's start. Now, the first item on our list is to create a producer. So let's click on the producer, and let's check what we have to do. We will use the Kafka Python library, which is the basic library allowing you to integrate Python and Kafka. So let's install it. Now that the library is installed, we can create a Kafka producer. And in order to produce data to Kafka, all we need to know is where to find Kafka, hostname and port, how to connect using SSL and 3 certificates, and how to serialize the data from JSON to a raw series of bytes, both for the key and the value. So we will use key and value, which will be JSON, and we will send them as raw series of bytes to Kafka. So let's create the producer now. And now that the producer is created, let's send our first message to Kafka. And the first message is a pizza order. It's Francesco, myself, sending an order for a pizza margherita, my favorite one. So let's send it. Now, the record is in Kafka. Well, how can I be sure that the record is in Kafka? Well, I need to probably read. So let's create a consumer now. Let's take the consumer. And the beauty of Jupyter Notebooks is I can have multiple notebooks running one against the other. So I create the consumer alongside the producer. In order to create the consumer, there is the Kafka consumer, and I need to pass kind of the same information. The client ID is just the name that I give to the consumer. Let's leave out the group ID for now. We will come back to this topic later. The rest of the information is kind of the same as the producer. Where to find Kafka, how to connect using the SSL certificates, and now how to deserialize the information that I was serializing before. So let's create the consumer. Now that the consumer is created, is ready, I can check which topics are available in Kafka. And I can see that there are some internal topics together with a nice Francesco Pizza topic that I just created for this purpose. Now I can subscribe to it and confirm the subscription. I subscribe to Francesco Pizza. And now I start reading from it. Okay, we started a thread that reads from Kafka, and we can immediately see two things. The first one being that the thread never ends. This is because we are creating now an event-driven application. So we will be always there waiting for Kafka to have a message ready for us. So we will check with Kafka, hey, do you have a message for me? No, we will wait, and then we will check again. The second thing that we can notice is that we produced an order for Francesco requesting a pizza margherita, but we don't see it on the consumer. Well, this is because by default, when you attach with a consumer to Kafka, you start reading from the point in time that you attach to Kafka. So since we attach with our consumer later than we produce our first message, we are not going to read it. This is the default behavior, and you can change that. But just remember that if you attach to Kafka without going back in history, you will start reading from the point in time that you attach to it. In order to provide you a demonstration that the whole pipeline producer and consumer is working, I will now send another couple of events. And this, now it comes the most kind of problematic part of my talk, because I have two new orders, one from Adele ordering a pizza Y, and another for Mark ordering a pizza with chocolate. Now, I believe you understood that I'm Italian. So ordering a pizza Y or a pizza with chocolate in Italy is not the best thing that you can do. However, it's your personal choice. You can do whatever you want. I'm just suggesting if you come to Italy, try to avoid them. So let's now send the orders, and let's check if the pipeline is working by checking on the consumer side if we can see them. So let's run the producer, and immediately we see that we receive both Adele and Mark order. So the whole pipeline, producer and consumer, is working. Now that we check the basics, let's go back to a little bit more slides. And let's talk now about the data in Kafka. So we said that Kafka and the topics in Kafka are append-only and immutable. This means that we will put data there, and once the data is there, we cannot change it. But of course, we maybe don't want to store the data in Kafka forever. Maybe we want only to use Kafka as storage for like the latest 6 months of our dataset. For this, we can use what are called topic retention policies. So we can tell Kafka, keep the events in Kafka, either for example, 6 months, 3 weeks, 2 hours, or if we want to be sure about how much disk is used, we can say, keep the data in Kafka until the specific topic reaches, for example, 10 gigabytes, and then delete the oldest chunk and let it grow again. It reaches 10 gigabytes and delete the old chunk. You can also use both if you want to have better control over both disk and size and timing. So let's now think a little bit more about the size and the size of the log, the topic. We know, and I've just told you, that Kafka is a platform that allow you to host a lot of events. But if you think that we store events in a topic, and that topic is stored in a broker, this means that either we have to define the amount of events that we want to store based on the size of the disk of the broker, or we have to size the disk of the broker depending on how many events we want to store in a precise topic, which is a weird trade-off for a platform that aims to store a huge amount of data. Because in case we have a huge topic, we will need huge disk sizes in order to store all the events related to the topic. Luckily for us, Kafka doesn't really impose this trade-off between number of events or size of the topic and disk size, because it has the concept of topic partitions. Topic partition is a way of dividing the events of the same type belonging to the same topic into subtopics. So if we go back to the analogy of my pizza orders, I could divide the events pizza orders into different partitions, depending, for example, from the restaurant receiving the order. So I could have Mario's order landing in the blue partition, Luigi's order landing in the yellow partition, and Francesco's order landing in the red partition. Now, if we go back to our cluster, what is stored in each node is not the whole topic, is just a partition. So this means that the trade-off is not actually between the whole topic disk size and the whole topic size and the disk size of a broker, but is between just a partition and the disk size of a broker. This also means that if we know that we will have a huge topic with a huge amount of data, but we have a smaller disk, well, we just need more partition to fit in. And as you can see here, also partitions are not stored once, but are stored following the replication factor of configuration. So this means that even here, if we lose a node, we are not going to lose any data. Now, it's interesting to understand how you select a partition when you create a topic with multiple partitions. Well, you do that usually using the key part of the message. And what Kafka does by default is it takes the key, it hashes it, and takes the result of the hash to drive the partition selection, ensuring that all messages having the same key will end up in the same partition. You can, however, write your own custom partitioner, or you can send messages without the key. In that case, Kafka will select a partition in round-robin fashion. But you may want to think carefully about which partition you select when you send a message. Why is that? Well, it's because ordering. Let me show you a little example. We have our producer in Python that produces data to a topic with 2 partitions, and we have our consumer. Now we will have a really simple case where we have only 3 events: the blue event first, the yellow event second, and the red event third. When pushing those events to Kafka, the blue event will land on partition 0, the yellow event will land on partition 1, and the red event will land on partition 0 again. Now, when reading from Kafka, it could happen, will not always be the case, but it could happen that we will read the events in this sequence: blue event first, red event second, yellow event third. Why is that? Well, because when we start using partitioning, we have to give up on global ordering. When we use partition, Kafka ensures that the correct ordering of events only per partition. So when we start using partitions, we have to think about for which order we care about the related ordering. In the case of pizza orders, it's a good example to use the restaurant name because we care about if client A made the order before client B at the same restaurant, but we don't care if client A made the order before or after client B on a different restaurant. So we understood that partitioning is good because allow us to have a better trade-off between topic size and disk space. On the other side, with partitioning, we have to give up on global ordering and Kafka only ensures the correct ordering per partition. But if we think about a topic, we can safely assume that it is just kind of a thread writing one event after the other as messages. So we can also somehow assume that the throughput of writing to Kafka is given by this thread writing one event after the other. On the other side, if we have more partition, we can scale out, because now with more partition, we have more independent threads that can write in parallel. So we can have many producer writing to Kafka, and also we can have many consumer reading from Kafka. Still, when we have many consumers reading from Kafka, we want to read all the data which are present in the precise topic, but probably we don't want to read the same message twice. We don't, for example, want to make the same pizza order twice. In order to avoid that situation, what Kafka does is that it assigns to each consumer a non-overlapping subset of partitions. If this word doesn't make much sense, well, let me show you in our example. We have 3 partitions, blue, yellow, and red, and 2 consumers. What Kafka will do, for example, is to assign the blue partition to consumer 1 and the yellow and red partition to consumer 2. Now again, after all this talk, it's time to show a little bit of demo. So let's go back to our notebook and let's check out now the partitions. Let's create a new producer. There we are. We create a new producer. It's not really needed, but let's create for the sake of creating. And now we will create a new topic, and we will interact with Kafka admin client, because for this new topic, we want to set the number of partitions to 2. So we create the Kafka admin client, and then we create a new topic called the same Francesco Pizza _ partition with 2 partitions. Let's run this. Okay, we didn't have any error, so the topic is created. Now, before start sending data, let me create 2 consumers. Let's go back to my set of notebooks. I can create the first consumer over here. And just to show you, I'm using kind of the same settings as before. Let me start the first consumer. And now let me start the second consumer down there. There we are. Let's close this. Okay, so I have 2 consumer, top and bottom, reading from Kafka. I have a topic with 2 partitions. Now, when I'm sending data, since I have 2 consumers, I'm sending 2 messages with a slightly different key. The top one has the key ed0. The bottom one has the key ed1. If everything works as I told you so far, I would expect that, for example, the top message lands in partition 0, and the bottom message lands in partition 1. On the consumer side, I expect, since I have 2 consumers, that one will only consume data from partition 0, and the other one will consume only data from partition 1. So let's check if all the theory is true. Let's send the dataset. And exactly as I told you so far, I have the top consumer reading only one of the message, and the bottom consumer reading only the other. If we check what those 2 little fields mean, this means that the top consumer is reading from partition 0, offset 0, first message of partition 0. The second consumer is reading from partition 1, offset 0, first message of partition 1. Now, if on the producer side, I send a couple more messages, reusing the same keys, I will expect that the order from Mark ordering a nice pizza with banana, since it's reusing the same key as the Frank order, will land on the same partition. And the same for Jan and Adele. So I expect Mark to be received by the same consumer that received the order for Frank, and the same for Jan and Adele. Let's try this out. Let's run this. As expected, the top consumer is reading from partition 0, offset 1, second message of partition 0, or reading the order for Mark. And the bottom one, same thing, Jan and Adele. So all working as expected. Now, let's go to a little bit more slides. So far, we saw something very simple. one or more threads of a producer, one or more threads of a consumer. However, when we read a message from Kafka, Kafka is not going to delete that message, making it available for other applications to read it again. If we go back to our pizza analogy, we could have our topic with, in this case, two consumers that could be our pizza makers. They want to consume all the pizza orders from the topic, but they don't want to read the same order twice. They don't want to make the same pizza twice. On the other side, since the pizza order is there, I could have my billing person that will want to receive a separate copy of all the pizza orders in order to make the bills. And this billing person will want to read the topic at its own pace that has nothing to do with the two pizza makers. With Kafka, it's extremely easy to do that because it has the concept of consumer group. So I just need to define the two consumer groups, the two pizza makers, part of the same consumer group. And then I will define my billing person as part of the new consumer group. If I do this setting, well, Kafka will send another copy of the same data in the topic also to the other consumer. And if you remember at the beginning, when I created the first consumer, I told you, well, the group ID was something that we will discuss later. Well, that group ID is actually how you define different consumer groups. So just a string lets you have multiple consumers working one against the other in order to consume all messages, or if you change the string, you will have the consumers defined as different applications. The last bit that I want to talk to you about is the fact that so far, we basically wrote the code to do everything. We wrote the code to push data to Kafka. We wrote the code to read the data from Kafka. On the other side, especially if Kafka is not the first tool in your company, you will have other tools in your data ecosystem. And you will want to integrate Kafka with those tools. And probably you don't want to reinvent the wheel again. You don't want to code all the interactions between any of your data tools and Kafka. It would be really nice if a pre-built framework could exist in order to make the integration really easy and reliable. Well, let me tell you another secret. That framework exists and is called Kafka Connect. With Kafka Connect, I can start integrating Kafka with any source or target available. For example, I have my data in a Postgres database or in Cassandra or in Google PubSub. I can use Kafka Connect to ingest that data into topics. On the other side, I have data stored in Kafka topics, and I want to send this data set to another technology in my company ecosystem. Again, Kafka Connect enables you to do that. Kafka Connect also enables you to evolve existing application. So if you have your old application in Python that was writing to a database, and you want to take this application into the kind of event-driven world, well, you want to do that, but still you don't want to change the working code. You want to leave the application and the database as they are working now. What you can do in order to include Kafka in the picture is to use some sort of change data capture mechanism that will track any changes happening in a table or a set of tables in the database and propagate those as messages in a Kafka topic. And you can do that easily with Kafka Connect. Also, Kafka Connect allows you to distribute events. So once you have your application writing data to a Kafka topic, and you have, for example, your team A that wants the data in a particular JDBC database, well, you can send a copy of that topic data to that database. You have another team that wants another copy in BigQuery, it's just another Kafka Connect. You want to use S3 storage for long-term storage of your dataset, well, again, it's just another Kafka Connect. The beauty of Kafka Connect is that it makes all this push and pull operation available just as config file and a thread or multiple threads of Kafka Connect. The other beauty that I will show you now is that with Ivan, you have also Kafka Connect as a managed service. So let me show you quickly. If we go back to our notebook, let's now get rid of a little bit of things that are not useful anymore. And let me create a new producer again, just for the sake of creating another new producer. And this time, I will not send only Francesco is ordering a pizza margherita, but together with that payload, I will also send some information about how the message is structured. So I will tell to Kafka, look, that the key is composed by an integer called ID, and the value is composed by two strings, one containing the name of the person ordering the pizza, and the other is the pizza itself. Why I'm doing that? Well, because I want to make the life easier for Kafka Connect to be able to understand what's the structure of each message and populate, guess what? A Postgres table with the content of this Kafka topic. So let's define the key and the value. And now I'm sending three nice messages to Kafka. I'm sending both the schema and the payload, as I said before, and I'm sending three messages, one for Frank ordering a pizza margherita, one for Dan ordering a pizza with fries, and one for Jan ordering a pizza with mushrooms. So the data now is in a Kafka topic. Let's check out Kafka Connect. I told you before, Kafka Connect, if you have a managed service like the one in Ivan, you just need a config file that tells which is the topic that you want to take the data from and which is, for example, your Postgres target. Let me show you the config file in our case. If we check the Kafka Connect setup, this is all the information that we have to give to Kafka Connect. So we are saying that we want to take the data from the Francesco Pizza schema topic, and we want to create a Kafka Connect connector called Sync Kafka Postgres, which is a JDBC sync connector. We are syncing the data to a JDBC database, which is a Postgres database. We are also telling that the value, what we store in the value, is a JSON. And this is the URL that we are going to use in order to connect to Postgres using a very secure new PG user and new password 123 as password. So let me copy this JSON configuration file, and let me now go to my Ivan services in the Kafka service. Now I can go to the connectors and create a new connector. This is fetching now the list of available connectors, and I'm selecting the JDBC sync. Now, here I can see a list of fields that I could fill manually, or since I have my JSON configuration file, I can copy and paste in here and click apply, and this will parse and fill all the parameters for me. So now I can create the connector, but before doing that, I want to show you that I'm not lying. So I want to show you the Postgres database, which is behind. So I have my Berlin buzzwords database. I'm connecting to it. I have my default database, the public schema, which has no tables. So now let me go back to my console and create my new connector. The new connector is created and now is running. All good? Let's go and check if something happened on the database. So let me refresh now the list of tables. Oops, not this one. Just a second, the GUI is doing tricks on me. Let's refresh the table. No. Yeah, sorry. This is the classic demo effect. No, wait. No. And no. Okay, let me try now to refresh the list of tables, and I have my Francesco Pizza schema table. If I double click on it, I can see that in the data, I have my 3 rows as expected, the same 3 rows that I sent before with my Python producer. Now, if I go back to my Python producer, and now I send another record with Giuseppe ordering a nice pizza, why? This is now produced. Let me go back to the database, and now try to refresh, and I immediately see also Giuseppe order appearing in the database. So what Kafka Connect did is it took the data from the topic, it went to Postgres, it found out that there was no target table, it created a target table, and it started populating the target table. And now every time there is a new event, a new record in the Kafka topic, it will send it to the Postgres table. So in order to go back to a little bit, understand what we told tonight, we understood a lot of things. We understood why create event-driven application is crucial. What is Kafka role in this? How we can use Python in order to interact with Kafka, to create producers, consumers, to have multiple consumers working one against the other and using partitions, and also to declare multiple applications. And we finished with some nice concept about Kafka Connect that allow us to integrate Kafka within the existing data ecosystem. If you want to have some more resources, well, let me give you them. First of all, it's my Twitter handle. You can reach out to me if you have any questions regarding Kafka, Python, or pizza choices. Then you have the first link, which is a GitHub repository containing the notebooks that I've been showing you today. So you will be able to create the resources automatically in Ivan, start playing with Kafka, and understand the beauties of Kafka within the Python notebooks. Then, if you want to try Kafka, but you don't have any streaming data set, well, I also created for you a nice fake pizza creation, fake pizza orders producer that will start producing fake pizza orders in a streaming mode for you. The last bit is, if you want to try Kafka, but you don't have Kafka, well, as said before, Ivan, my company, offers that as a managed service. And we offer not only Kafka, but also, as said, Kafka Connect and Mirror Maker. So just come there. We have a nice free trial that lasts 1 month. Just check us out, and please let me know what you think about it. I hope in this 40 minutes, I gave you an idea of event-driven applications, Python, and Kafka. If you have any questions, I'm here to reply to all of them. Thank you very much.
Thank you, Francesco. We have one question. The first is, I saw you use Jupyter Notebooks in your demo. Are there other tools that you like to use with Kafka?
Yeah, so there is a really huge ecosystem around Kafka. One which I like is Kafka Cat, which is a tool that allows you to basically from the command line to interact with Kafka. So you can start producing data to Kafka, you can start reading data from Kafka, and it is especially useful when you start with Kafka, especially when you start writing your own code against Kafka, because you could, as I said earlier on, for example, you can start reading from Kafka, but you miss all the messages that were sent before you attach to Kafka with a consumer. With Kafka Cat allows you with few flags and fields to fix all these items. So you can actually use it in order to understand if your code is doing what you're expecting, if the data looks as you expect, and so on and so forth.